Hello, in this video we're going to look at how to write solutions of trigonometric equations so that you capture all the solutions at once. And essentially you basically use an integer to do that. So you capture infinite solutions. So the basic strategy though is to come up with what I call it a generator, and that's my terminology. And essentially you begin with one angle, you find the first solution in the solution set. And generally that angle is either comes from your calculator or your knowledge of the unit circle. And that angle is usually like the first positive angle closest to 0. And then you add an integer value times the distance between two consecutive solutions, right? All right, so let's take a look at that. Oh, sorry. Let's say we're looking at this right here. Here's the graph of sine x, and we want to know for what angles is the sine of those angles equal to 1. Now, we can see just by inspection that here's where sine is 1, right there, right there, right there, going this way here, here, and so on and so forth infinitely, right? So what I can see then is the first solution, if I just look visually, is exactly in the middle between 0 and pi, so that's pi over 2. And of course, from your knowledge of the unit circle, you know that. And then if you kept going, this would be what? 5 pi over 2, right? So you're adding another 2 pi, you can see that. And so here you can see between 2 and 3 is 2.5 pi or 5 pi over 2. So what's the distance between this? So if we look at 5 pi over 2 minus pi over 2, we get 4 pi over 2, which is 2 pi. So we just see that the distance between the first two solutions we looked at is 2 pi. Okay. Now let's look at the next solution. It's exactly in the middle, right, between 4 pi and 5 pi. So it's 4.5 pi, which is 9 pi over 2. Now if we look at the distance between 5 pi over 2 and 9 pi over 2, right? 9 pi over 2 minus 5 pi over 2 is 4 pi over 2. It's 2 pi. So the distance between here and here is 2 pi. And so obviously you could see a pattern. If I go this way, I'm between negative pi and negative 2 pi. So I'm at negative 1.5 pi or negative 3 pi over 2. And again, if you look at the distance between pi over 2 and negative 3 pi over 2, so pi over 2 minus a negative 3 pi over 2 is 4 pi over 2 or 2 pi. So the distance between here and here is 2 pi. And I bet you can find then the next solution, you're going to find that the distance between this and this is 2 pi. So this is going to continue on infinitely. So one way I could express my answer, and by the way, this is negative 7 pi over 2. One way I could express my answer is I could say, well, here you have dot, dot, dot. That means going on forever and ever in that direction. Negative 7 pi over 2, negative 3 pi over 2, pi over 2, 5 pi over 2, 9 pi over 2, and dot, dot, dot. And you're saying going on forever in that way. So you could express your answer that way. But let's come up with a little bit better way, and that is by saying, well, okay, let's see if we can find like a little formula to capture all of these forever and ever. So if you start with one of the angles, what you notice is they're how far apart? Well, if you look at the graph, I started here. If I jump 2 pi ahead, I get to the next one, solution. If I jump 2 pi ahead, right, add 2 pi, I get to the next solution. If I add another 2 pi, I'm going to get to another one. Or if I subtract 2 pi, I get here. If I subtract 2 pi, I get there. So really, I could say theta plus k times the distance, right? Between what? The distance that is the same distance between any two consecutive solutions. So I would say pi over 2 plus k times 2 pi, right? And then we'd like to clean that up. This is fine. For some reason, people love to write 2k pi. It just makes it prettier. That's all it is. Okay. Now, from there, what happens is we can generate if you were given this, which is the solution here, and it captures all of them, if you were given this and you were asked to find solutions, all you'd do is put values of k in there that are integer. So if I put in negative, let's say, and by the way, since I'm here, this one would be -2, right? From where I started, this would be 1, 2 in the negative direction. So if I put in k equal to -2, I expect to get -7 pi over 2. So let's try it. So I would have theta then equals pi over 2 plus 2 times -2 pi. Well, that's going to be pi over 2, plus a -4 pi, right? Or pi over 2, let's see, we want to make that 2 over 2, so it's going to be what? -8 pi over 2. And there's your -7 pi over 2, which is what we expected. Okay. And of course, if you put in other values like k equal to -1, you'd have theta equal pi over 2. We'll just kind of clean that, -2 pi, which is pi over 2 minus 4 pi over 2, or -3 pi over 2, right? And that's what we see over here. And so on and so forth. You can get all of these, right? If I put 0 in, of course, I just get pi over 2, and so on and so forth. Now, just to make a little point here, I started at pi over 2, right? The angle that's closest to 0 and positive. But I really could have started anywhere. I could have started at -7 pi over 2, right? Let me just show you a point. If I had said, oh no, this is the answer, I could say at -7 pi over 2 plus 2k pi. And that works just as well. It's just not what we use by convention. By convention, we use the angle closest to 0 and positive. But, for example, let me just show you, if I wanted to get, let's say, the 5 pi over 2, how many jumps is that? 1, 2, 3. That would be k equal 3, and I should get 5 pi over 2. So let's try it. K equal 3 into this generator. I would have theta is 7 pi, -7 pi over 2, plus, I'm moving forward, so it's positive, 2 times 3 pi, right? So I'd have -7 pi over 2 plus 6 pi, which is -7 pi over 2, and then that's plus 12 pi over 2. And so indeed, look, that's going to be positive 5 pi over 2, which is what we expected, right? We said if we start here, we go 1, 2, 3, 3 sets of this distance of 2 pi forward, we get a 5 pi over 2. So again, your generator really can be any theta, and then k times the distance between any two solutions, right? You know how many times to move forward or backward to get to all your solutions. So, or to put a specific one, in this case we tried. All right, so now how would we do this? I'm doing this by inspection, right, where I showed you the graph and I said, look, you can see that the answer is here at when it's sign at 1. How would you do this if you were actually solving it on a unit circle? Well, you would do this. You'd ask yourself, when is sine, let's say, of an angle equal to 1? And you'd say, well, I know on my unit circle, the y-coordinate is 1 up here at pi over 2. Is it 1 anywhere else? Nope, just at pi over 2. So my first solution is pi over 2. When's the next time I get there at this position? Well, I have to go all the way around the circle, which is 2 pi. Or I can go all the way backwards, right? That would be -2 pi. Or I could do what? Go around the circle twice, which would be 4 pi. Or I could go back twice, to be -4 pi. So basically what I see is, what kind of rotation does it take to get back to the same place? It takes k times 2 pi. Right? That's how I would see it on the unit circle. Okay. All right, let's take a look at another example. Clean up some of this mess I have here. Let's take a look at solving this one. So let's say you were asked, here's the graph of sine x, for what angles is x, the sine of x equal to 0? So for what angles do you basically hit the x-axis? So go ahead and pause the video and see if you can come up with a generator. All right, so hopefully what you did is you said, okay, here are my solutions, right? Boy, there's a lot of them. And how far apart are they? Well, it looks to me that the distance between here and here is pi. Between here and here is another pi. Between here and here is another pi. Is it consistent all the way through? Yep. Seems like all the time, all I have to do is move pi to get from one consecutive, what means they're right next to each other, from one solution to the next. So it looks to me like I can start at a solution, and honestly you can start at any solution, but we usually start at the one closest to 0 that's positive. Well, that would be just 0. That's the closest thing you can get to. So here's 0 plus k times the distance, in this case is pi. Now we could drop the 0 and just say k pi, right? So you could see if k is 0, you get this. If k is 1, you get pi. If k is 2, you get 2 pi. If k is 3, you get 3 pi. If k is -1, you get negative pi. If k is -2, you get negative 2 pi. So you get them all. Now, how would you do this on the unit circle? Well, on the unit circle, you would say, where is sine of theta equal to 0? So I'm asking for what angle is the y equal to 0? So where is it that y is 0? Here and here. So that'd be at 0, pi, and so on and so forth. So you're saying, well, that's, if I start at this solution, what's the distance? What do I have to rotate to get to the next solution? You rotate pi. And then I'm at the next solution. So I'm at the next solution now. So that'd be like saying I go from here to here. Now that I'm on this solution, what do I have to rotate to get to this one again? But now this one's going to be called 2 pi. So I have to go another what? Pi. So that'd be like going from here to here. And so on and so forth. I could also go backwards and do the same thing. So what I would notice is I would start at 0 and then go plus k pi, and again just say k pi. So it works, of course, on the unit circle also. All right, let's try another one. All right, so this one is, these pens really bleed through. So let's say I want to solve for where is tangent squared x equal to 1. All right. Now, by inspection, so by visually looking at it, here's 2, in the middle is here at 1, right? So I could see it's going to be here, 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 and all that sort of thing. I can see it here. So where is that? Well, it looks like it's in the middle between 0 and pi over 2, so it looks like it's pi over 4. Right, so I think it's right here, pi over 4. Well, what about here is another one, right? So we've got it here, 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 right? Here, here. These are all my solutions coming out. So when I look here, this one is between, in the middle between pi over 2 and pi. So that looks like 3 pi over 4. So does it look to you like they're equidistant, or you'd maybe have to do a little bit of work to make sure that you're reading them correctly? So let's see. Here it looks like it's what? Between pi and 3 pi over 2, right? So that's going to be 5 pi over 4. And then here, this one is between 3 pi over 2 and 2 pi, so that's going to be 7 pi over 4. If we go this way, I could see that this is negative pi over 4, and so on and so forth. So I could see this is between negative pi over 2 and negative pi is negative 3 pi over 4. So let's take a look. Visually, what do you think the distance is? So like, what's the distance between these two? So pi over 4 minus a negative pi over 4 is 2 pi over 4, or what? Pi over 2. So what I can see is the distance here is pi over 2 between those two solutions. Well, let's take another two solutions. Let's take between 3 pi over 4 and pi over 4. So 3 pi over 4 minus pi over 4. That's 2 pi over 4, or pi over 2. So it looks like this is also a distance of pi over 2 between two consecutive solutions. Well, let's see. Is it also here? 2 pi over 4, yes. 2 pi over 4, yes. Go back, 2 pi over 4, yes. So it looks like the distance between any two solutions is what? 2 pi over 4 or pi over 2. So how would I write my generator? I would start with an angle. Usually you start with your first one that's positive closest to 0, which would be pi over 4. So I would say pi over 4 plus k times the distance, right? So in our case, I would say pi over 4 plus k times what? Oops, k times pi over 2. And usually they would write that pi over 4 plus, just like that, k pi over 2. All right? So that's what we would get this way. Now let's see how we would do this if we were solving it algebraically. And, well, I'm solving algebraically and then using your unit circle. Because honestly, what happens? Do you really get this graph every time you want to solve something? No, of course not. I'm doing this so you can actually see what we're doing, and hopefully it makes sense. So now let's see what would really happen. You would get this. Tangent squared of theta, for example, or x, doesn't matter, equals 1. And now you start using some algebra. So this is the same thing as tangent of theta squared, right? It's the whole thing is squared equal to 1. The function is squared. So now I want to take a square root of both sides, right? And the square root of this squared would be absolute value of tangent theta. And of course, absolute value 1 is 1. Now, I would say tangent of theta is plus or minus 1. Right? Then I would come, so this was the algebra. Now I have to start using trig. And essentially I have to solve two separate things. Either where's tangent theta equal to negative 1? Where's tangent theta equal to positive 1? Right? So remember, this is asking for what angle is the ratio y over x equal to negative 1. And then this is asking for what angle is the ratio y over x equal to positive 1. Okay, that's what it's asking. So where is it on your unit circle that your x and your y are exactly the same, but one of them's positive and one's negative? So you would say, oh, okay, that's over here at 3 pi over 4, right? Because you have square root, see, negative square root 2 over 2, and then positive square root 2 over 2. So their ratio, y over x, would be negative 1. But also over here at 7 pi over 4, right? Here it's positive square root 2 over 2 and negative square root 2 over 2. Right? What about this one? It would be here at pi over 4, and then over here at 5 pi over 4, right? So you have positive square root 2 over 2 and positive square root 2 over 2. So they're both positive. Here they're both negative. So their ratio is positive. So essentially what you get then is you could use the generator. If you use the generator on this, you'd say, well, let's start at 3 pi over 4, right? And what's the distance between 3 pi over 4 and 7 pi over 4? Well, it's 4 pi over 4, which is 1. So when you subtract 7 minus 3, you get 4. So 4 pi over 4 is pi. So you'd say plus k pi. And what about here? What's the distance between here and here? And you can see that the distance is going to be the same. If you kept going, you said, what's the distance? You'd have to come up with a new name for 3 pi over 4, the next coterminal angle, right? So you'd have to add 2 pi, which would be 8 pi over 4. So it'd be 8 plus 3 is 11. So then you'd have, what's the difference between 7 and 11, and so on and so forth. And you just find that every time it's just pi away, right? And here the same thing. You'd find that you could start with a generator, which would be pi over 4, and say plus k pi would get me all these solutions. Now, but if you put it all together, which is really what we want to do, because we want to capture all solutions anyway, let's see if we can put them all together. To put them all together, what you'd have to say is, are all consecutive solutions equidistant? So here's pi over 4. So we got pi over 4, we got 3 pi over 4, we have 5 pi over 4, and we have 7 pi over 4. So the real question is then, can we put these two that are separate, can we put them together? I think we can, because what's the distance between here and here? Well, what's 3 pi over 4 minus pi over 4? It's 2 pi over 4, which is pi over 2. So this distance is pi over 2. What's this distance? Well, 5 minus 3 is 2. 2 pi over 4 is pi over 2. What's this distance? Pi over 2. What's this distance? Pi over 2. Of course, here, again, you just have to rename this. You'd have to see that this coterminal angle would be a new angle called what? 9 pi over 4? So then 9 minus 7 is 2. 2 pi over 4 is pi over 2. So anyway, since the test is when I start at one solution, do I always go the same distance to get to the next solution? if I do, and I can capture all the solutions, then I can use this generator thing where I say, okay, start at a solution, usually my first positive solution, and add k times the distance. So I would say pi over 4 plus k times pi over 2. And that would just be pi over 4 plus k pi over 2. And what we see then is that's what we got over here, right? That's what we were seeing here. Now, it might strike you as kind of funny that they're all positive 1. I'm not sure if that here we solved for where's tangent theta negative 1, but remember, this is getting squared, so when you square negative 1, you get positive 1. All right, let's try yet another one. All right, so pause the video and see if you can find where is, visually, sine of 2x, this is the graph of sine of 2x, where is that equal to 1, right? And this is 1 right here. Right? So see if you can find those angles just visually. Pause the video, see if you can find them. All right, so what you would find then is, here this is being divided, from 0 to pi, you've got 4 divisions. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and so on and so forth. So it looks like my first solution is where? Pi over 4. And then here, it looks like my next solution is, here's 4 pi over 4, 5 pi over 4. So 6 pi over 4, 7 pi over 4, 8 pi over 4. The next one is 9 pi over 4, right? Keep going. So on and so forth. This would be 13 pi over 4. If we go backwards, we're going back this far, right? So we're got negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. And if you kept going, this would be negative 7 pi over 4. Okay. And then negative 11 pi over 4. All right. So the question to ask yourself is it the same distance between any two consecutive solutions? Well, let's take a couple of them and try it. Let's take the distance between here and here. So 5 pi over 4 minus pi over 4 is 4 pi over 4, or pi. So here the distance is pi. What about here? Well, 9 minus 5 is 4. 4 pi over 4 is pi. It looks like that's true. 9 and 4 is 13, so yes, it looks like this is also pi. Going this way, I'm going pi over 4 minus a negative 3 pi over 4 is 4 pi over 4 pi. So again, pi. So it looks like, yeah, this is holding up, right? So how would I write my generator? Start, generally, by convention, at the first positive solution, right? Pi over 4. And add k times the distance, k pi. So that will be your generator. Now, do I have to start at pi over 4? No. I showed you in the first example, you could start at any of the solutions, and the k will take over and get you to all the solutions just by adding however many sets of distances you go back and forth to get to another solution. Right? All right. And finally, here, let's take a look at cosine x. Oh, well, anyway, we'll see how to solve this later, you know, algebraically. I just want I want to just focus on how to set up or express infinite solutions when you get them. So here, cosine x, let's take a look if we can solve where is cosine x equal to a half, right? And hopefully you see that here's a half, and here's pi, this is what? Pi over 3. And of course, on your unit circle, what you'd want to do, so I'm showing you here on the graph that this is, the next time it hits is at 5 pi over 3, and then 7 pi over 3, then 11 pi over 3, and so on and so forth. Going this way, you have negative pi over 3, negative 5 pi over 3, and so on and so forth. So on your unit circle, if you were solving this, what you would do is you'd say, okay, if I'm looking for cosine of an angle equal to a half, right? Where is it that, for what angle is the x-coordinate, right? For what theta is x equal to a half. So x is a half, positive a half here. Both at pi over 3 and Right, so this angle and this angle, 5 pi over 3. Okay. Now, are these equidistant? Well, let's take a look at our graph. If I try to go from pi over 3 to 5 pi over 3, what's this distance? Well, it would be 5 pi over 3 minus pi over 3, which would be what? 4 pi over 3, right? Well, now let's take a look at the distance between this and this, the next one, this and this. So now I would say, okay, between 5 pi over 3 and 7 pi over 3, 7 pi over 3 minus 5 pi over 3, well, that's 2 pi over 3. And I can see on the graph there, I can see this distance is longer than this one. And so you get a long and a short, a long and a short. You can see that these are not equidistant. So I can't begin at one solution here and add the same distance and get to all the other solutions. I can't do that. There's not one formula that will work. So now what do we do? Well, you have to handle them separately. So what you do is you have two separate generators. What you'll end up having is one generator for these here that are green, because these are how far apart? Well, let's check. 7 pi over 3 minus pi over 3 is 6 pi over 3, or 2 pi. So this is 2 pi apart. And then this one and this one here at 13. So 13 minus 7 is 6. 6 pi over 3 is 2 pi. Right? So this is going to work for this. And then you can go backwards here. This is going to be 2 pi also this way. For the other ones, we'll do these in purple. When we're at 5 pi over 3, we go to 11 pi over 3. Well, 11 minus 5, so, oh, it says purple, but it's not. 11 pi, let's see, is that right? Yeah. Over 3 minus 5 pi over 3, that's 6 pi over 3, which is 2 pi. So I could see these are 2 pi apart, right? So this one and this one are 2 pi apart. So at least there is some consistency. You just have to separate them. And then what you'll see then is you have two separate generators. You have this one, put that in green, that's pi over 3 plus 2k pi. And then you have this other one in blue, this one up here, where you probably would start at 5 pi over 3 and add 2k pi. Right? So we have to have two separate ones. This one and then this one. This is the first positive angle closest to 0 for that set, and this is the first positive angle closest to 0 for that set. And you see it on the unit circle, because here, if you look at the distance between this and this, right, you're like, I can see that if I rotate, I start at this solution and I rotate, that's a lot bigger rotation than if I start at this solution and I rotate to this, right? So this is a much smaller rotation. And when I see that they're not equidistant, they're not the same amount of rotation, then I know I'm going to have to just say, oh, well, give me this one, pi over 3, and at least I can go around 2 pi in either direction, positive or negative, and I will capture them all. And then give me this one, 5 pi over 3. And again, if I'm standing here and I go 2 pi, or negative 2 pi, negative 2 pi, I'll capture all of them. And that's what I'm showing you here. Right? Either this sequence or that one. All right? Thanks so much for listening.